So for example, on the sheet that I gave you here, okay, whoa, that's way too zoomed in. Okay, so what we've got going on, and this is really important for Physics 30, this is not going to be on your exam tomorrow because I don't really care to test it right now, but it is important for those of us who are going on to take Physics 30. When you have waves, here are some waves, and they're traveling in that direction. They're propagating themselves in that direction, so they're going up. The waves come across two openings, and they're right beside each other for all intents and purposes, very close to each other. Now remember that when a wave hits an opening or hits a slit, it will disperse, okay? Or it will diffract, sorry. The bending of the wave as it goes through this opening is called diffraction. Now, it will diffract here through this opening, and it will also diffract here through this opening. So what that means is you've got, everywhere you see a line, that's a crest. Well, what has to be halfway in between these lines? In between a crest and a crest has to be a trough. And what do you know always happens when a crest of one wave meets a trough of another wave? What will happen? They will cancel out to some extent, right? What kind of interference do we call that? There's a word that we use for that kind of interference. Destructive interference. So let's take a look at this in real life, okay? So I don't know. I've been told we have this apparatus. I just don't know how to set it up. Nobody's taught me how to set it up yet. And so one of these days I will actually figure it out. I apologize about that. But for right now, we just have this. So this is what's called a wave table. So there's water on here. There's a light source above it. And there's 2 points. And these points are going to oscillate up and down with the same frequency. And they're going to be in phase with each other. So these 2 points are going to go bam, 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 bam. But they're going to do it in the water, and it's going to be a little bit faster than that. We're going to be able to see the effect of the waves as they interact with each other. Now, keep in mind here that you have crests and troughs interacting with crests and troughs from both of these 2 point sources. So the water table or the wave table is going to recreate this at these points. That's where the 2 point sources are going to create the waves. Okay, so here we go. Let's try this, and it's on mute right now, but it doesn't really matter. It's all good. So it's just showing you the setup, and then it's showing you what to see below it. There we go. So I'm just pausing it right now to show you this is like a very instantaneous perspective of what we're looking at. But I'm going to unpause it here, and I want you to remember that what we're seeing is an actual video. So this is the pattern that's going to be created, but it's created many, 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 many times a second. There we go. So it's going and then it's stopping, and then it's stopping, and then it's stopping. So I don't know, can you see, is there something interesting that's happening? It's really weird. It almost looks like the sides we don't care about. That's not that big of a deal. But kind of down below, there's some weird optical illusion type thing going on. Okay, let's go back and we'll start it back up again. It's almost like the waves are really only happening in certain locations. Do you know what I mean? So like I don't know if you can see this, but do you see waves there? I see waves there, but then there's like a gap in between that I don't know. Do you see any waves there? I don't see any waves there at all. Interesting. Why? Why is that the case? Why are there no waves there at all? Josh. That's where crests and troughs are canceling each other out. And so same thing here. I see array of waves traveling out in a straight line that way, but then I see nothing. I see no waves in any way, shape, or form there. And then I see array of waves, no waves, waves, no waves, waves, no waves. Can you see the same thing on your sheet? It's hard to see, but can you see the same thing on your sheet? Okay, where are the rays of waves? Why would we have waves to begin with? Like sometimes they're canceling each other out. That's destructive interference. So why would we have waves in the first place? Because sometimes it's not destructive interference, sometimes it's constructive. It's constructive interference, right? Now remember, each line is a crest. So where you see one crest overlap the other crest at that location right there, what do you know? When a crest and a crest interact with each other, what happens? Do they add together or do they subtract from each other? They add together. That's constructive. And so let's take a look at all the places that we have constructive interference. So, okay, would you agree? So we got constructive interference right here, right? Crest, crest, but also crest, crest, but also crest, 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 crest. Do you see how that constructive interference is, for the most part, creating a straight line propagating in that direction? And so if there was a wall over here, if there was a wall, oh my God, over here, you would see the maximum wave amplitude in that, oh my God, what am I doing? You would see it in that location. I don't know, does that make sense? That's where we would see it. And how many waves, how many constructive wave patterns do you see here? So this is one. This is where you're going to get a maximum here. How many maximums do you see sweeping across the page? You tell me. You look at your sheet. Don't look at my screen because my screen's not perfect. It's imperfect. Look at your sheet. How many maximums do you think you're going to see? I count 5. I see 1, 2, 3, 4, 5. It should kind of make an optical illusion on your page. You know what I mean? Okay. So what I'm going to see, again, if I had a screen, if I had like a wall here or something like that, I would see a maximum wave here, a maximum wave here, a maximum wave here, a maximum wave here, and a maximum wave here if I kept it going. Okay? This is what we call a diffraction pattern. And you see this anytime you pass a wave through two openings, or anytime you have 2 point sources of a wave interacting with each other. So the one in the middle, that's what we call the central maximum. This is the first order maximum. This is the second order maximum. And it's only because the distance between the point here and the point here, would you agree the distance is the same for both of these things? Is that okay? So as long as they're in phase with each other to start with, which they came from the same wave, so they are, as long as they're in phase there, as long as the distance is the same, they'll always be in phase. In phase, 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 in phase. If it's in phase, that means crest and crest meet at the same time. Boom, constructive interference. But any point here, let's take this point right here. It's on the gray line, which means that's a crest for the gray wave. But it's in between crests for the black line. So what does that mean? It's a crest for the gray line, but if it's in between two crests for the black lines, what does that mean? It's a trough for the black line. So what are you going to get right here? Is that constructive interference or destructive interference? That's destructive. Everywhere along this line, boom, line in between two lines, line in between two lines, line in between, line in between, line in between, line in between, line in between. And the reason why is because the distance, and I'm just going to erase it because it's getting too busy, okay? The distance between here and there, here and there, and the distance between here and there are off by half a wavelength. If things are off by half a wavelength, instead of crest and crest meeting, what's half a wavelength away from a crest? A trough. Does that make sense? So it's a crest and a trough that are going to meet. Now we can affect this pattern in a bunch of different ways, okay? So when we look at some of the other pictures that are in this booklet, okay, so what's the difference between this diffraction pattern and that diffraction pattern? Is there more maximums? Draw the maximums, draw the line for each maximum on this page. Yeah, if you want a ruler, use a ruler, but draw the line for the maximums. Remember, it's anywhere where crest and crest meet. There should be a line. Maybe it creates an optical illusion. Are there more maximums? How many maximums do you see? 7. This is to page 2, right? So you got a maximum here. You got a maximum here, here, here. It's really hard for me because I'm super close to the screen, so it's kind of hard for me to see them. Woo! There we go. I don't know, does anybody know what was the key difference between this picture and the previous picture? What did I change about that picture and that picture? I'm curious. Nope. Okay, so the frequency, what would the frequency change? The frequency would change the wavelength, right? If we change the frequency, it would change the wavelength. So let's look. You tell me, is the distance between waves the same? So all I'm going to do is I'm going to go from here to here. That's the distance between black waves, right? Between black crests. So let's go back up to the top one. And is the wavelength any different? It's not substantially different. Would you agree? So the wavelength hasn't changed. Although, had we changed the wavelength, yes, we would have changed the pattern. That's one thing that would have changed the pattern. Okay, so what's the big difference? What's changed between these two things? It's the distance between what? What do you mean points? I'm going to go from center to center of the openings. Is the distance between center to center of the openings, is it different? Yes, it is. Are we okay with that? This one is from here to here. It's larger. And so we've created a different pattern. All I want you to do, all I want us to do is try and determine what are the things that affect the angle of diffraction. So there should be 2 waves here, 2 diffraction patterns. What's the big difference between them? I tried to really exaggerate it this time. Oh, yeah. It's the distance between openings, right? Okay. So we're gonna go. If I write this down, it's not gonna travel with the page, but I'm gonna write it down anyways. Whatever. So it's the distance between. I'm gonna say sources, because those are the sources of the waves. But like you could say distance between the openings. That's fine. So that's one way you could affect the angle of the dispersion pattern. What else? What else could affect it? Let's go to the next page. Is the distance different? No. What the frequency is, which directly what are we seeing as a result? Because you don't see frequency. You don't see how many times per second are they oscillating, Rufus? The wavelength. But that it's because you change the frequency, right? Yeah, 100%. So are the waves closer together or further apart in the top one? They're closer together. So what does that mean? The angle between two maximums, is the angle wider or more narrow because the wavelengths are tighter together? What do you think? Yeah, I think the angle is more narrow here. It's a tighter angle between maximums if the wavelength is shorter. So all we did was we changed the frequency, which meant the waves were closer together, and that affected the angle of the diffraction pattern. All right, are we okay with that? This is important for Physics 30. I did have to talk about it. It's in the program of studies. I'm forced to talk about it. It's not a big deal at the Physics 20 level. It's not going to be on your exam tomorrow. It's not going to be on your final exam. But this is a thing for those of you who are going on to Physics 30. It is expected you remember a little bit of information about two-point interference patterns when it comes to waves. Because you're going to do literally an entire unit on waves. It's going to last 30 to 35% of the semester in Physics 30. So we have to remember stuff about waves. Good? Okay. All right. We're done. That's the last piece of new information. What do you mean, are you getting your test back? Your quizzes? Yeah, so if I apologize if I told you that the exam tomorrow is going to be chapter 7 and 8 combined. I apologize, it's not. It's just on the checklist for chapter 8. So it's just, when you look at the checklist for chapter 8, that's it. That's all that's on there. If I recall correctly, last semester I was really tight for time and I just wanted to focus on the chapter 8 stuff. So when we look at the checklist for chapter 8, that's all that's going to be on there for the exam tomorrow. So you have 2 options for the remaining 55 minutes in class. There's approximately 55 minutes left. What I want you to do is I want you to choose either this to work on, or, and I'll put the answer keys out for this as well, if I remember to print them off, which I can't remember if I did. Or there is a stations activity out on the lab bench right now. Now I'm kind of done. I'm done asking you to go out there and do stations activities. I find they're more fun. I also find that I learn better by doing activities like that as opposed to review booklets like this, at least at the beginning. I find that's more engaging. It preps my mind. It kind of primes my mind. And then when I'm done a few questions out there, then I come back in here and I'm good to go. I've got kind of got a routine and a rhythm. So I encourage you to go out there and do the stations activities. The only problem is I made them last night fairly late and there is no answer key for them yet. But you can just bug me and I'll just say, yes, that's correct, or no, that's not correct, that kind of thing. So I'm going to put the answer keys for this thing out, or print them out if I haven't already. I'm going to put one up here and one over on that lab bench. And then if you want to head out to do the stations, go right ahead.